Imagine floating in the deep dark emptiness of space, utter silence, no air, no sound, just endless black and distant stars. There's nothing to carry a whisper, no wind to brush your suit, only the cold, infinite void pressing in from all sides. It's a place where you're completely alone, surrounded by the vastness of the cosmos. Space seems peaceful, almost serene, but that silence is deceiving. The calm is just a mask, hiding dangers that lurk in every shadow and every ray of light. The universe is a violent arena filled with dangers far beyond anything on Earth. Explosions, collisions, and forces so powerful they can tear apart entire worlds happen regularly out here. Out here you could freeze instantly in the shadow of a planet, be cooked by deadly radiation from a nearby star, or be shredded by a tiny rock moving faster than a bullet. Even the smallest piece of debris can become a lethal projectile. Drift too close to a black hole and gravity crushes everything, matter, light, even time itself. There's no escape from its pull. Supernovas can sterilize entire solar systems in a single blinding flash. Gamma-ray bursts can wipe out life across galaxies in moments, sending waves of energy that travel for billions of years. But among all these threats, one object stands out, not the biggest or darkest, but the most extreme, the most mysterious. It's the crushed core of a dead star, a cosmic zombie with powers that seem to defy the very laws of physics, a remnant left behind after unimaginable destruction. This is a neutron star, a spinning beacon of danger and energy, the final, collapsed form of a massive star that didn't quite become a black hole, but came terrifyingly close. It's the universe's way of showing just how far matter can be pushed. Think of it as the universe's most dangerous consolation prize, a tiny object with the mass of a sun, squeezed into a sphere the size of a city. It packs more danger into its tiny frame than almost anything else in the cosmos, unleashing forces that can be felt across light years. Its properties are so extreme they challenge the very laws of nature, bending space, twisting magnetic fields, and warping time itself. Forget what you thought was dangerous. The neutron star redefines the word, setting a new standard for cosmic peril. In the universe, sometimes the smallest things are the deadliest. Let's find out why this tiny star is the ultimate cosmic threat. What exactly is a neutron star? It's one of the most extreme and mysterious objects in the cosmos, a true marvel of astrophysics that pushes the boundaries of what we know about matter and gravity. It's born when a massive star runs out of fuel and its core collapses in a spectacular supernova explosion, blasting its outer layers into space and leaving behind a dense, compact core. The core is squeezed so tightly by gravity that protons and electrons are forced to merge, creating a ball of pure neutron matter, something you won't find anywhere else in the universe. Imagine the mass of Mount Everest crushed into the size of a sugar cube. That's the kind of density we're talking about here. It's almost impossible to comprehend. Just a single teaspoon of neutron star material would weigh about 6 billion tons on Earth, enough to outweigh a mountain or even a small city. This tiny object is so dense it warps the very fabric of space-time, bending light from distant stars and creating bizarre optical illusions. It's the densest thing you could ever hope to see with a telescope. A typical neutron star is only about 12 miles across, smaller than most cities, yet it packs more mass than our entire sun into that tiny space. All the mass of a giant star squeezed into a sphere smaller than Manhattan. It's like fitting the weight of the world into a single city block. Its gravity is so intense that it flattens any bumps or mountains. The tallest mountain on a neutron star is less than a millimeter high, almost perfectly smooth. The surface may look calm, but don't be fooled. It's blazing at 1,000,000 degrees Celsius, hotter than almost anything else in the universe. This is not a gentle place. It's a perfect sphere of death, blasting out deadly radiation and magnetic fields that would destroy anything that comes too close. The combination of unimaginable mass, tiny size, and searing heat makes neutron stars the universe's ultimate heavyweights, true champions of the cosmos. They are cosmic paradoxes, tiny yet unimaginably powerful, able to unleash energy that rivals entire galaxies. These are some of the most dangerous and awe-inspiring places you could ever imagine, where the laws of physics are pushed to their limits. And we're just getting started. The story of neutron stars is only beginning to unfold. What if you tried to visit a neutron star? First, deadly radiation, X-rays and gamma rays would destroy you long before you got close. Suppose your ship could somehow block the radiation. Next comes the magnetic field. Neutron stars spin rapidly, creating magnetic fields trillions of times stronger than Earth's. These fields would rip your atoms apart and vaporize your ship. Survive that? Gravity is next. 200 billion times Earth's gravity would flatten you instantly. You'd never reach the surface. Tidal forces would stretch you into spaghetti long before. Even a marshmallow dropped from a meter above would hit with the force of 1,000 hydrogen bombs. No material or technology could withstand these forces. Approaching a neutron star is a one-way trip to total annihilation. There is no surviving this journey. It's the deadliest destination in the cosmos. Some neutron stars become pulsars, cosmic lighthouses with deadly beams that sweep through the universe. These objects are among the most fascinating and extreme phenomena in the cosmos, capturing the imagination of astronomers and science enthusiasts alike. As they spin at incredible speeds, their intense magnetic fields channel jets of radiation from their poles, creating focused beams of energy that shoot out into space. These beams sweep across the cosmos like the beam of a lighthouse. If one happens to point at Earth, we detect a regular rhythmic pulse, hence the name pulsar. Pulsars are cosmic clocks, their pulses so precise that they rival atomic clocks. But their beams are also lethal. High-energy particles moving at nearly the speed of light, capable of destroying anything in their path. Any planet unlucky enough to be in the path of these beams would have its atmosphere stripped away in moments, leaving the surface barren and lifeless. Life stands absolutely no chance under a pulsar's relentless and unforgiving bombardment, making these regions of space some of the most hostile environments imaginable. Some pulsars spin hundreds of times per second. Despite being more massive than the Sun, they rotate faster than a blender, packing immense energy into a tiny space. Their energy output is staggering, a leftover from their violent birth in supernova explosions, sending shockwaves and radiation across the galaxy. Over millions of years, they gradually slow down, but even the slowest pulsars still spin several times a minute, continuing to send out their deadly signals. When first discovered in 1967, scientists were so baffled by their regular signals that they wondered if they'd found evidence of extraterrestrial intelligence, naming the first one LGM-1 for Little Green Men. Instead, they had uncovered nature's most extreme physics in action, revealing the incredible power and mystery of the universe. Pulsars are a stark reminder that the universe's clocks can also be its deadliest weapons, timing the cosmos, but with a lethal edge. Sometimes two neutron stars orbit each other in a deadly dance. Over millions of years they spiral together, losing energy as gravitational waves. When they finally collide, a kilonova, the explosion is brighter than 1 billion suns. In that instant, the universe forges heavy elements: gold, platinum, uranium. These precious metals are blasted into space, seeding future planets. The gold in your jewelry likely came from such a cosmic collision. In 2017, scientists detected both gravitational waves and light from a neutron star merger, a breakthrough confirming these events create heavy elements. We witness the universe's forge in action, hundreds of millions of light-years away. Even the most violent events can create beauty and value. Neutron star collisions are the universe's ultimate alchemy, destruction and creation side by side. Could a neutron star ever threaten Earth? Thankfully, the answer is no. The nearest known neutron star is about 400 light-years away, far too distant to ever harm us. Its gravity, radiation, and magnetic fields are completely harmless at this range. Even a supernova would need to be within 50 light-years to actually pose a threat. The stars near us are stable. Our solar system is in a quiet, peaceful part of the galaxy. The universe is violent, but its vastness ultimately keeps us safe. We can study these cosmic monsters from afar, marveling at their power without any fear. We often think the biggest things are the most dangerous, but neutron stars prove otherwise. By squeezing a sun's mass into a city-sized sphere, the universe creates objects with unimaginable power. Neutron stars force us to rethink our place in the cosmos and test the limits of physics. They are both destroyers and creators, seeding the universe with elements for planets and life. The same event that creates gold can sterilize a galaxy. The cosmos is a place of balance, creative and destructive, beautiful and terrifying. Next time you look at the stars, remember the tiny spinning remnants hiding in the darkness. The smallest giants are among the universe's greatest masterpieces.